Probability. Probability is the likelihood or chance of an event occurring. And the formula for probability is number of ways of achieving success over the number of total outcomes. For example, if I have 10 people in the class and I want to know how many are girls. Suppose girls are 3 and boys are 7. So if I select one person at random, what is the probability of a girl being selected? 3 out of 10. And the probability of boy being selected is 7 out of 10. This is possible outcomes. This is total number of outcomes. Does that mean everybody has the same chance of being picked? Yes, because we will be studying simple random events. Random event means that whenever you have a number of outcomes, for example, in this case 10 people, every person stands an equal chance of being picked. That is a simple random event. The probability of one person being selected will not be higher than the other person being selected. Rather, the probability of each and everything being picked will be equal. That's why they are called as random events. Let's have a look at the questions. There are 6 beads in a bag. There are 3 red, 2 yellow. There are 3 are red, 2 are yellow, and 1 is blue. What is the probability of picking a yellow bead? Probability of picking a yellow bead. How many total beads are there? 6. And how many yellow beads do we have? 2. So the probability is 2 upon 6 or 1 upon 3. You always simplify the probabilities. Let's have a look at the other question. There's a bag full of colored balls, red, blue, and green. Red, blue, green, and orange. Balls are picked out and placed. John did this 1,000 times and obtained the following results. Blue balls being picked out is 300. Red balls being picked out is 200. Green balls being picked out is 450. And orange balls being picked out is 50. What is the probability of picking a green ball? How many times did he pick the balls? Out of 1,000. Probability of picking a green ball is equals to 450 upon 1,000. You will simplify it and this turns out to be 9 over 20. If there are 100 balls in the bag, how many of them are likely to be green? This is the probability, 9 out of 20. So how many balls are likely to be green? 9 out of 20 balls are likely to be green. Right? Okay. Then we have kinds of events. This was a single event that only balls are being picked up. Right? Then we have multiple events. One kind of event is an independent event. Means the outcome of one event does not depend on the outcome of the other event or is not affected by the outcome of the other event. For example, if we throw 2 dice, then what number occurs on dice number 1 is least bothered by what occurs on the second number, and the outcome for any number occurring on both the dices will not be impacted. You will always see the word fair dice, fair coin. Fair dice or fair coin means that the chances of all the numbers on the dice occurring is the same. It's a fair dice. Fair coin means the probability of heads and tails occurring is the same, which is 50-50. So, when we are talking about a dice, so the probability of each number occurring on the dice is 1 upon 6 because every number is written once and the total numbers are 6. Other one is mutually exclusive event. A mutually exclusive event is the are two events which cannot take place at the same time ever. They are impossible to occur together. For example, when a coin is thrown, it will either show a head or it will show a tails. Both of them cannot occur simultaneously on the coin. Next concept is that of a probability space or a sample space. Sample space, the type of sample space that I have taken here is sum of numbers that are shown on two dice when two dice are thrown together. These are the numbers appearing on one dice. These are the numbers appearing on the second dice. And everything written inside this grid is the sum of two numbers appearing or occurring on both the dice. For example, 1 plus 1 is 2, 2 plus 2 is 4, 2 plus 2, where do we write 2 plus 2? 2 here and 2 here, means it will be written here, right? So all the numbers inside this sample space, they denote the sum of numbers that appear on both the dices. Now, first question is, p greater than 6 means you have to calculate the probability of the sum being greater than 6. So what is the probability of numbers of the sum being greater than 6? It starts from here, and all of the numbers which are enclosed in this triangle are the possible outcomes. How many possible outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 out of how many outcomes? 21 out of 36 outcomes. Right? So 21 out of 36 outcomes. I will write 21 out of 36. We will simplify it. It turns out to be 7 on 12. Probability of sum being 6. How many 6s do we have? 1, 2, 3, 4, 5. So 5 upon 36. 1, 2, 3, 4, 5. Sum equal to 6 is 5. 5 upon 36. Probability of sum being greater than 12 is 0. Because the sum is not greater than 12, rather it's only equal to 12. Probability of the sum being multiple of 3. So, how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. 12 out of 36, which is 1 upon 3. 12 upon 36 is equals to 1 upon 3. And probability of the sum being odd, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Right? Sum being odd is 17 upon 36. That is the answer. Sample space can be something like a coin is flipped. 3 coins are flipped together. Draw a sample space. So it will be heads, heads, heads. This is one possibility. Right? This is coin 1, this is coin 2 and this is coin 3. So heads, heads, heads. First coin heads, tail, heads. Heads, tails, tails. Right? Then we have tails, head, head. Tails, tails, head. Tails, tails, tails. Then we have tails, head, tails. Then we have heads, heads, tails, and we will see how many outcomes we can get. 3 coins are flipped how many times? Once, right? These are the possible outcomes. How many outcomes do we have? 2. How many coins are flipped? 3. The number of outcomes should be 8. Number of possible outcomes and the experiment, the number of possible outcomes will be 8. If you don't add up to 8 outcomes, then you will have to see what you have missed out. But here you will see that you do have 8 outcomes. 1, 2, 3, 4, 5, 6, 7, 8. Right? So you have 8 outcomes. This is your sample space. Sample space can be the same, but it will have multiple or product of two numbers occurring on the dices. In place of 2 here, then you will write 1, and in place of 3 here you will write 2, because 2 multiplied by 1, and so on. The products will be filled inside the grid instead of sums. Let's move to probability trees. We need to remember something, that for example, when we are flipping the coins, the probability of heads and tails is the same, means 0.5. The sum of all probabilities has to add up to 1. If it's not adding up to 1, we are doing something wrong. Even for a dice, I said probability of all of them occurring is 1 by 6. If you add all the 1 by 6, means adding 1 by 6 times, you will get sum of probabilities equal to 1. Right? 6 upon 6 equals to 1. Now, let's draw a probability tree and let's see how we draw the tree. There are 3 balls in a bag, red, yellow and blue. One ball is picked out and not replaced, and then another ball is picked out, not replaced. You start the experiment. First you pick, there are 3 balls. 3 balls in the bag. Names are red, yellow and blue. Probability of all of them occurring is 0.33. 0.33 or 1 upon 3. Instead of 0.33, I am going to write 1 upon 3. 1 upon 3 plus 1 upon 3 plus 1 upon 3 adds up to 1. Right? One ball is picked out and not replaced, then another ball is picked out. Now, either you will pick a red ball, or you will pick a yellow ball, or you will pick a blue ball, right? This is not replaced. If a red ball is picked, then chances are on the second pick you will either get a blue ball or a yellow ball. If you have picked a yellow ball, then on the second pick you will either pick the red ball or the blue ball. If you have picked the blue ball, then on the second pick you will either pick the red ball or the yellow ball. Chances of both of them will be 50-50. 0.5, 0.5 or 1 upon 2. Let's make it 1 upon 2 because these are 2 balls. Right? 1 upon 2, 1 upon 2. The sum of all branches, first one, there are 3 branches, sum should be equal to 1. Then 2 branches, sum should be equal to 1. 2 branches, sum should be equal to 1. 2 branches, sum should be equal to 1. Right? Now, here you have to find out the probability. This is the probability tree. Now, you have to say probability first ball is red, which is 1 by 3. 1 upon 3. Simply, probability first ball red is 1 upon 3. Probability first ball red and second ball blue. First ball red and means multiply. Second ball blue. First ball red or first ball green, yellow. So probability first ball red or means add first ball yellow, right? This is and or. This is how you draw a probability diagram. Let's do another question of probability tree that can be done from this as well. Two bags of counters, bags A and bag B. There are 5 red counters and 3 blue counters in bag A, 4 red counters, 5 blue counters in bag B. Tina takes at random a counter from each bag. Complete the probability tree. In the bag A, we have total of 8 counters. So 5 upon 8 and this is 3 upon 8. When you add these two, answer will be equal to 1. Okay, in bag B, how many red counters? 4. Total of 9. 4 upon 9, 5 upon 9. 4 upon 9, 5 upon 9. This is how you complete the tree diagram. Work out the probability that Tina takes 2 blue counters. Right? 2 blue counters is this. First blue and second blue. First blue and second blue. You will multiply both of them and the answer will be 5 upon 24. This is the probability that she takes both blue counters. Now, if this is that she takes the red counter, both red counters or both blue counters, both red or both blue. So, this will be red and red, red and red, or both blue. Both blue we have already calculated 5 upon 24. This is or and this is and. This is how you utilize the tree diagram. Let's see if we have any coin questions from the tree diagram. Okay. John plays a game where he can win, draw or lose. Probability John wins a game is 0.5. Probability that the game is drawn is 0.3. The probability of lose is 0.2 because all of them should add up to 1. So this will be 0.2. Complete the probability diagram. Okay, winning the game 0.5, 0.3 draw, lose 0.2, again 0.5, 0.3, 0.2, 0.5, 0.3, 0.2. Work out the probability John wins both the games. So this is win and win means 0.5 multiplied by 0.5. If they say probability that John loses one game, not the first game, loses one, wins the other. So there are a few options here. Either he wins the first one, loses the second one, or he loses the first one and wins the second one. So this will be 0.5 multiplied by 0.2 or 0.2 multiplied by 0.5. This isn't the case that all the time probabilities are going to be the same, but if they are same, doesn't really matter. Alright? Okay. Now let's go to the or and rule. I have just explained that, but let's have a look at the example. Probability example, what is the probability of getting a yellow and red in any order? That is the same question that we did earlier. Red and yellow will be picked, means probability of red and then probability of yellow. Probability of picking a red or yellow, 1 upon 3 plus 1 upon 3. Right? So this is the and or rule. Probability of red, yellow and red, yellow and red, and probability of the yellow and red means first ball is yellow, second one is red. Probability is 1 upon 2 for the second one. Red and yellow, same thing, red and yellow. Probability yellow and red, yellow and red, or red and yellow. Okay, this is how you are going to calculate these. Then we have conditional probability. What is conditional probability and how do you write it? You write it like this. Given that another related event has already occurred. For example, probability that it will rain this afternoon given that it rained this morning may be different to the probability that it will rain this afternoon given that it was sunny in the morning. Okay, conditional probability basically occurs when the events are not independent, rather they depend on each other. How do we write given that? PA and this slash B means probability of A occurring given that B has already occurred. The formula is probability of A intersection B upon probability of B. Given that, whatever is given that will come in the denominator. Right? Okay. Now let's have a look at the examples of conditional probability. Students in a class. A girl is chosen at random from the class. Find the probability that this girl walks to school. Boy and girl walks, uses public transport and uses car. There are 26 girls in the class that can be indicated after adding all the girls. Question is asking a girl is chosen at random. So find the probability that this girl walks to school, means probability of choosing a walking student, probability walking given that this is a girl. Given that this is a girl means we have to find out probability of walking intersection girl upon probability of a girl. Walking intersection girl is 15 and total girls are 26. Right? So this is conditional probability. Let's do another question. Venn diagrams, earlier we did sets and we have a question of probability in sets also. Let's see how do we do that. Can be calculated. Venn diagrams, when an event occurs given that it is in a specific region. Calculate A given that B intersection B complement means B does not occur. Here means not B. B dash, which is B complement, means not B. means probability of A occurring given that it is not in the region B. So that will be 15 in the numerator. Given that it's not in region B, so we are going to add the ones that are not in region B, which is 15 and 5, that is 20. Right? So the answer will be 15 over 20 or 3 over 4.